Okay, my name is Jim White with Shermco Industries. So this is my standard disclaimer slide, and I have to put this up because as a member of the NFPA committees listed here, as well as ASTM, I have to point out that what I'm giving you is my opinion. This is not an official interpretation. I can't give official interpretations. Only NFPA or ASTM can provide official interpretations, and if that's what you need, then you need to contact those standards associations directly and ask for an official interpretation. So what I'm giving you is my opinion. And I've been on the NFPA 70E committee since 2001, so I've been on it several cycles. I have quite a bit of experience. I understand why we did what we did. And that can be important because I've seen a lot of people misinterpret some of the different things that we put out. And it's a shame because we go to great lengths to try to make the standard as clear and understandable and usable as we can. But of course, people interpret things based on their own experience. The slides that I'm going to show you are written in legislative text. And it gets a little confusing because there's a lot of lines and stuff going on. And any text that has a strike through means that for the 2018 edition, that text is being removed. Any text that is underlined means that it is being added for the 2018 edition. If it doesn't have a strike through or it doesn't have an underline, then that means that it is existing text in the 2015 edition and is not being changed. So I have some of that to kind of try to give the context of what we're doing here. Because like I say, it gets a little confusing even for me sometimes. If you see any text in red, that means it's not really in the 70E. It's just things that I put in there to try to clarify a little bit, and you won't see that in the 70E. Here's an example. This is out of 130.4. The title used to be Approach Boundaries to Energize Electrical Conductors or Circuit Parts for Shock Protection. We took all that verbiage out, and now it's just shock risk assessment. And where it did say shock risk assessment, it just says general, and then we just compress things down. A shock risk assessment shall be performed as follows. So all that verbiage that was in there was, in this case, it wasn't actually taken out. It was put into more of a list format. We found that the list format is more understandable and clear than embedding it into a paragraph. So we're adding a new section for job safety analysis. Now, with the NFPA 70E, the job safety analysis is only looking at the tasks that you do, and then you do an analysis as to the hazards, the severity, and the likelihood of injury. And then you list the control methods. So basically, the job safety analysis is looking at, is it safe to do this task? And if it can be performed safely, then you move on to the next step, which we'll talk about here in a little bit. So the job safety analysis is new. We didn't have it in any other section. You can see we have an informational note for an example of a job safety analysis. See informative annex, and there's no number. And by the way, just kind of a note about the numbers. All of this is based on the first draft. We're getting ready to do the second draft in June, and I'm sure that we're going to change a lot of things when we get into the second draft. So that means the numbering that you see probably is going to get changed around. Some things are going to be dropped, some things are going to be added. it's a whole new ball game when we get into the second draft meeting. So this presentation is really based on the first draft, although I'm going to comment on what I think will, or especially if I think maybe it won't be in the second draft, and then I'll comment on that. But it might. I mean, you just never know. Under 110.1H, notice there's a lot of existing verbiage. Subtopic number 1 talks about electrical safety programs shall include a risk assessment procedure. And then we've added subtopic 2. It says the risk assessment shall take into consideration the potential for human error and its negative consequences on people, processes, work environment, and equipment. And then we added the informational note, the potential for human error will vary with factors such as task and the work environment. And I don't know if you've heard this, but I've heard it. It's like 75 to 80% of all incidents are the result of human error. I don't know if that's true, but I mean, I don't have anything to show that it's not true. But whatever the actual number is, the fact that human error plays a big factor in all types of accidents is undeniable. And what we're saying is, look at the job that you're about to do, try to assess what human errors could occur, and then try to put in a procedures and process to try to eliminate those human errors. So can we do that completely? No, of course we can't. The old saying that any good thing that you do can be completely ruined by a person is pretty true, because people make mistakes, and sometimes they make mistakes no matter what you do. But you try to put in processes and procedures so that if a person does make a mistake, that it limits the safety effect, and if at all possible, you eliminate that person from making a mistake. Tough to do, I know, but we try to do it. That's what safety is about. 110.1H again, number 3, preventative and protective risk control methods shall be implemented in accordance with the following hierarchy. So we have elimination, which is removing the hazard, and I have as a note here, turn it off. Substitution, replacing something that produces a hazard with something that doesn't, like installing arc-resistant switchgear. Engineering controls, isolating workers from the hazard. And a good example of this is using remote racking devices, remote operators, instead of standing in front of the equipment and doing it. Awareness, making workers aware of risk or hazards by the use of signs, warning lights, things of that nature. Administrative controls, changes to the way workers perform tasks. Procedures and procedure changes, changes to processes, training, all become administrative controls. And then you'll notice the very last one, personal protective equipment, reduces the effects of the hazard and attempt to make the injury survivable. I always like to point out that PPE is the least effective method of controlling risk, and because of that, we don't want to rely on PPE. The best thing to do is to eliminate the hazard. So once you're working down the list, you get more and more ineffective. And here's a good slide from ANSI Z10. Now, Lanny Floyd presented a paper at the IEEE Electrical Safety Workshop a couple of weeks ago that was held in Jacksonville, Florida. And he said, really, when you talk about eliminate the hazard, you're talking about a permanent elimination and not a temporary elimination. So his point was eliminate the hazard during design. And then substitution, substitute less hazardous equipment, system, or energy, such as reducing the voltages, putting in control transform. So you take it from like 480 down to 120 or even something less. But the idea is reduce the voltage, reduce the short circuit current, do something so that it's a less hazardous work environment. Engineering controls, design options that automatically reduce risk, warnings, permanent or temporary, visible or audible warning systems, signs, barriers, labels, could be warning lights, strobe lights, administrative controls, planning processes, training permits, safe work practices, and then personal protective equipment. So we're going to add a new section after 110.1H, incident investigations. Now, most companies have in place something to investigate incidents. The electrical safety program itself shall include a requirement to investigate electrical incidents. This was kind of an oversight on our part in past editions of the 70E, so we're kind of plugging that hole here. We get into job safety planning and job briefing. In previous editions, we kind of lumped them together, and they're really two separate things. So what we did was to strike out, you notice all the verbiage pertaining to job briefing is being struck out, including the part that says additional job briefing shall be held if changes that might affect the safety employee occur during the course of the work. That's going to be added in later. But right now, this part is to concentrate on job safety planning. Before starting each job that involves exposure to electrical hazards, the employee in charge shall complete a job safety plan and conduct a job briefing. And then specifically, what is the job safety plan? Well, it has to be completed by a qualified person, it has to be documented, and then it has to include the following information. Description of the job and the individual task, identification of the electrical hazards, a shock risk assessment, an arc flash risk assessment, and then work procedures involved, special precautions, and this is where you're really doing the planning. You're planning out with the job safety analysis. You're just trying to determine, can I do the job safely? Now I've determined that I can do the job safely, and I get into the job planning. Once I get the job plan covered, then I conduct the job briefing. It says the job briefing shall cover the job safety plan or the information on the energized electrical work permit. If you look at an energized electrical work permit in Annex J of the 70E, really that is a job safety plan, because you're putting all the information that you really need for an assessment and the plan right on that permit. And then number 3 is where we add the change in scope back in. Additional job safety planning and job briefing shall be held if changes occur during the course of the work that might affect the safety employees. We call job creep or task creep. And what happens is you're working on something and you go from possibly a de-energized state to an energized state when you're troubleshooting equipment, because really that's what most people do in their job is we troubleshoot equipment. Several years ago, there was an accident involved a friend of mine, and he worked for a field service company, and the guy was really sharp, very well qualified, and because of that, he was promoted to be the service center manager in a service center, and he got a call out in the middle of the night by a utility, and he went out to the power plant, and he was met by the supervisor and a technician. And as they started troubleshooting the equipment, the problem was that the breaker would not rack into the cubicle. So as they started troubleshooting the equipment, the shutter was down and everything was guarded. So they decided they needed to remove the shutter on this 15 kV breaker in a generating station in order to troubleshoot the circuit breaker. And according to the OSHA report, when they were removing the shutter, a grounded metal part of the shutter fell down and made contact with an energized stab on this 15 kV breaker. Now, you're only maybe, 100 feet, 200 feet from a generator. So the short circuit current is tremendous at that point. According to the OSHA report, it created a fireball that was 26 feet in diameter. So there was a tremendous explosion. The technician in the cubicle was killed immediately, and then my friend died 3 days later. The supervisor died 5 days later. So you had 3 fatalities from this. And one of the things that OSHA wrote as a citation was that when the job changed, that they didn't stand down and reevaluate the job. And, they were probably tired. They were probably, wanting to get this done. So they get it back into operation, a lot of pressure. And they just didn't consider how much energy would be available if something went wrong. And, part of the problem is we never think anything is going to go wrong. But in this case, it did, and 3 people died. OSHA came in and assessed almost $500,000 in fines. And lack of training was one of them, not wearing PPE. But this was one that they also cited as a willful citation. So when you get in a situation where the job requirements change and you have to go from a less hazardous situation to a more hazardous situation, you're required to stand down and reevaluate the safety aspects. 110.2c, emergency response training, says refresher training shall occur at a frequency that satisfies the requirements of the certifying body. And it used to say annually. And really, I was good with that being annually because electrical workers are at more risk than the general population or even other workers. And you look at things like the American Heart Association, they recommend CPR training every 2 years. And that's fine for the general work population. But for electrical workers, it's inadequate. And I can tell you, here at Shermco, we do CPR training every year. And from one year to the next, there's things that I forget. Plus, I don't know if you've ever done CPR training on a real person. Personally, I have not. But I can imagine it's a lot different than, doing CPR on the plastic mannequin and doing one on a real person. It's got to be a lot different. And if you aren't trained, if it's not fairly fresh in your mind, I don't know how good of a job you can do. So we struck the word annually. I would recommend if you have people that require CPR training, they do it annually. We're adding an informational note. Employees responsible for responding to a medical emergency might not be first responders or medical professionals. Might be the guy standing next to you. And that person requires training according to NFPA 70e. So we note that it could be a crass person or somebody else, but whoever is going to be the first responder in any given situation. And a lot of companies, I know their security force will be first responders, or they may have a medical professional that's a first responder. If you can't be reached within 4 minutes, according to OSHA, then you got a problem. And you got to train a person that's going to be with that other person. Test instruments and equipment in 110.4. We struck rated for circuits and equipment, and we added some things into a list format. Now, it still says rated for circuits and equipment where they are utilized, but then it says it has to be approved for the purpose, used in accordance with any instructions provided by the manufacturer. And, people do some silly things with test equipment. They try to use one piece of equipment for something that it simply isn't designed to do. Manufacturer may tell you to do certain things, and you decide, you know what, you know better than the manufacturer, so you skip that step. Can't do that. Got to use it the way that it's supposed to be used for the purpose. Operation verification. We're going to get back to this part where it says voltage is equal to or greater than 50 volts AC or 100 volts DC, because That's a global change that was approved by the committee now. In the first draft meeting, it takes 51% to make a change. And I don't think that is going to survive second draft, but that's my opinion too. But it says the operation of the test instrument shall be verified on a known voltage source. That's been existing. Then we say of the same frequency, AC or DC. So that's an important thing, because I may be able to pick up a voltage that's close by, but it may not be AC if I'm testing DC, or vice versa. So what we're saying is, if it's an AC source, you have to test and verify your test instrument on an AC source. Then we go down, we say informational note. Verifying the operation of an auto-ranging test instrument rated 1000 volts or less can be done on a known voltage source operating at a voltage other than that that's being tested for the absence of voltage. And if you have an auto-ranging meter, that's fine. If you have a meter that you have to change the range selector switch, that would not be appropriate. If you have an older meter that still has a range selector switch, you have to test that meter in the same voltage range as that you're about to test for the absence of voltage. So auto-ranging meters, you can go up to 120 volt outlet and test it. For a meter that has a manual range switch, because that range switch could be bad at the range that you actually need. So you have to test it on that specific voltage if it's a manual ranging meter. Article 120, we didn't really make any changes to the verbiage as much as we just reorganized everything. And this is the order that we'll put it in. We feel that it has a better flow. It's a more logical flow, and it will make the use of the Article 120 a little easier. The other thing we did, any training requirements we put back into 110.2. So all the training requirements that was in 120 is no longer in 120. It's now been put into 110.2. And now we get into the first revision, and this was a global, which means everywhere that you would have 50 volts AC is now being changed to 50 volts AC or 100 volts DC. And you can see that the tables are referenced here, 130.4DA. In the current edition, it's 130.4CA. But the numbers are changing because we're adding some tables and moving some things around. But the other thing to take note of, you notice where it has the symbol for less than, we're striking all of these abbreviations, and we're putting in the verbiage. So where it says less than, we're striking the symbol for less than, and you can see 130.4dB says less than 100 volts. That's a problem. Here's table 130.4 CB, which will be DB in the new edition, I think. We struck out the table, or the symbol for less than, and we put in the verbiage less than, because we feel that that'll make it more understandable. But less than 100 volts is a problem. And here is a letter of interpretation written by OSHA that addresses this issue. And this was actually presented at the 70E committee meeting, and a lot of the committee members chose to ignore it. They feel that they can change OSHA's opinion on things, which I think is an interesting concept. It's the tail wagging the dog theory. So I don't think it works that well. So question 1, does electrical guarding requirements of 1910-303 apply to voltages below 60 volts DC? And the response is 1910-303 generally requires live parts of electric equipment operating at 50 volts or more to be guarded against accidental contact by use of approved cabinets or enclosures. The guarding requirement does not distinguish between AC and DC voltage. Therefore, the requirement applies to live parts operating at 50 volts or more AC or DC. And the second question, if 1910-303 applies to live parts operating at 50 volts or more AC or DC, will OSHA treat a failure to guard live parts operating below 60 volts DC as a de minimis violation? Now, de minimis violation is an interesting thing because what they're saying is you actually have a technical violation of an OSHA regulation, but OSHA does not feel that it puts people at risk. So they go on to say a de minimis violation occurs when an employer deviates from the requirements of a standard in a way it has no direct or immediate relationship to employee safety or health, in other limited circumstances in which the employer's non-compliant actions provide employee protection equivalent to or greater than that afforded by the applicable standard. An example of this is when Class 00 gloves came out. There was no ASTM test method that had been approved at the time, but OSHA recognized that the gloves did not place people at risk, so they wrote a de minimis violation for several years until ASTM added 00 gloves to their standard. So you would get a de minimis violation, but it wouldn't cost you anything and it wouldn't really go against you. That's the kind of thing they were talking about. They go on to say failing to guard live parts operating at any voltage over 50 volts DC is not as protective as or more protective than guarding those parts and does have a direct relationship to employee safety. So that's not a de minimis violation. You point out in your letter that some consensus standards consider live parts operating between 50 and 60 volts DC to be non-hazardous. However, OSHA considers all voltages of 50 volts or more to be hazardous. They go on to talk about electric current. As explained in Appendix C, the internal resistance of the human body is 500 ohms, which is the minimum resistance of a worker with broken skin at the point of contact. Now, OSHA always looks at worst case scenario. The current through 500 ohms from a live energized part at 600 volts would be 120 milliamps, and this level of current, AC or DC, is sufficient to cause serious injury. And they go on to say, we are aware of documented cases where serious injuries occurred when employees contacted live parts operating between 50 and 100 volts DC. So they give some examples, and it's clear that as far as OSHA is concerned, if you're using anything more than 50 volts or less as your criteria, you're going to be in violation with the OSHA regulation. OSHA is going to cite you. Now, the NFPA 70E correlating committee, that is the committee that's above the 70E committee, has sent this back to the technical committee, the 70E committee, to reevaluate. And there's several problems. Number one, it's in conflict with OSHA, and in the forward of the 70E, it specifically states that the NFPA 70E meets all OSHA regulations. Well, if we do this, we're not in compliance. So that's a problem. Number two, the NFPA 70E is supposed to correlate with the National Electrical Code. If we do this 100 volts DC, we no longer correlate with the National Electrical Code. So therefore, it's one of those situations where we can be technically correct, but you could still be cited because we're telling you to do something that OSHA is specifically saying you should not do. So I don't know how this is going to come out in the committee vote, but my advice to you is to not use less than 100 volts, even though it has it in the table, use less than 50 volts, because that is the OSHA requirement. 110.2A4 used to say normal operation. Now we're going to call it normal operating conditions, because that's really what we were talking about. So we say normal operating condition, where operation of electric equipment shall be permitted, or I should say normal operation of electric equipment shall be permitted where a normal operating condition exists. And we have the same things, properly installed, properly maintained, no evidence of impending failure. We add number 3. The equipment is used in accordance with instructions, including the listing and labeling, and in accordance with the manufacturer's instructions. If they tell you to use a stop-start button, you're not allowed to go up to the breaker and use the breaker to stop and start it. You got to use a stop-start button. If you do anything else, any different operation, then it's no longer normally operating. And that's really what we mean with that number 3. 130.4 shock risk assessment. As you can see, we reduced the title of that section from approach boundaries to energize electrical conductors or circuit parts for shock protection to shock risk assessment. Just trying to make things more clear. Sometimes on a committee, you try to make things precise, you try to make things clear, and you add words and add words and add words, and you defeated your original purpose. So I think I'm a big proponent of less is more. So we say a shock risk assessment shall be performed as follows. And then we go through the list. Identify shock hazards, estimate the likelihood of occurrence, potential severity, determine if additional protective measures are required, including the use of PPE. And if you do need PPE, then you have to identify the following items: the voltage to which the person will be exposed, the boundary requirements, and the PPE required to protect against the shock hazard. So I really feel this clarifies that whole section much better than the way that we had it. Something we didn't have before, but was implied but was not stated, that the shock risk assessment shall be documented. I mean, if you look at the Energized Electrical Work Permit, that is a shock risk assessment that has to be documented. But we just didn't say it. So now we are saying it. We get an arc flash risk assessment, same thing. You really have the same requirements. You identify the arc flash hazards, estimate the likelihood of occurrence and the potential severity, and if you need PPE. And of course, you have to identify what PPE is going to be required. Number 2, estimate of likelihood and severity shall take into consideration the following items: design of the electrical equipment, including its overcurrent protected device and its operating time. Huge, huge item. If an overcurrent protected device, say you're using a molded case breaker, and for whatever reason you change that to a different type of overcurrent protected device, maybe you're going to fuses or whatever, that will affect the operating time. And by changing the operating time, you will change the amount of incident energy. The rule of thumb is that incident energy is proportional to time. So if I increase the time, I increase incident energy. If I decrease the time, I proportionally decrease incident energy. Then we get into B, the electrical equipment operating condition and condition of maintenance. For the last 3 cycles, this has been a huge topic within the committee because we don't feel that people are performing the maintenance that they should be performed on their overcurrent protected devices. The guys working on electrical systems, this is the only thing they have to really protect them. If that overcurrent protected device, whether it's a breaker or a fuse or whatever, if it's not being maintained properly, then the manufacturer's specification for its operation may not be valid. And to give you an example, let's say we don't maintain a molded case breaker. A molded case breaker should operate in 2 cycles or less. That's on the instantaneous. Well, if because of the lack of maintenance it now operates at 4 cycles, what we have done is to double the incident energy that a person would be subjected to. And again, incident energy is proportional to time. And even though we're only talking cycles per second, if you double the operating time, you double the incident energy. And that's why maintenance of these devices is so critical. Table 130.5 is a brand new table. We're taking table 130.7 C15AA, and we're cutting it down and massaging it a little bit, and we're moving it from the table method, we're moving it into the main text in 130.5. And this is, I just see this as a huge benefit, because before you really couldn't use that table unless you were using the table method. And that table did provide some guidance as to the likelihood of the occurrence of an arc flash. By moving it into 130.5 as a standalone table, now you'll be permitted to use that table to estimate the likelihood of an arc flash. Now, in Article 205, or not our article, but Section 205, I like to say Chapter 2 is the chapter that nobody ever reads. But one of the things we talked about on the NFPA 70E committee is if you don't meet the requirements of Chapter 2, you can't meet the requirements of Chapter 1. If you don't maintain overcurrent protected devices, you don't know what their operating time is going to be, and therefore, Chapter 1 is out the window. How do you choose protective equipment when you don't know what operating time is? So it's very critical to do that. But 205.3, in an informational note, and I know I said we try to make things clear in the 70E, and for some reason, we decided to use very unclear language. We could have talked about putting on a label or a decal, but instead we call it local indication. Common industry practice is to apply local indication as to the date and overall condition of specific devices that have been tested and maintained in the field. The local indication provides the employee immediate indication of the last maintenance date, and if the tested device or system was found acceptable on the date of test. And that's important, because you test it, it's good on that test date, but as you move through time, it's less likely that it's going to meet all those criteria. This local information can assist the employee in the assessment of overall electrical equipment maintenance status. And what we're really referring to is in the NFPA 70B, recommended practice for electrical equipment maintenance, we have section 11.27, and it has these three labels. Because the 70B is a black and white document, but if you read the verbiage in there, it talks about a red label, a yellow label, and a white label. And by the way, this same requirement is in ANSI NFPA 7, ANSI NETA maintenance testing specifications. And they both have the same type of labeling requirement. If I have a white label, what that white label indicates is that on that date, that piece of equipment was fully functional and ready for continued service. If I have a yellow label, that means that the equipment has some minor defect that does not affect safety or operation. Let's say it's got a cracked cover or a broken handle, cracked handle, something minor. But it needs to be addressed, but it's not something that you really have to do right away. A red label, however, means that there is a problem and you do need to address that as quickly as you can. Preferably, you don't put it back into service. But if it has to go back into service, you know that's a problem. You're going to fix it right away. As a technician, I can walk up to a piece of equipment. I can look at the label color. Shoot, I can look at that label color from a distance. And if I see that it has a yellow label, I'm going to start asking questions. If it has a red label, I'm really going to start asking questions. So it provides immediate indication of the equipment condition. Now, the only fly in the ointment is as I move away from the test date, if I get, say, 3 years, and I use 3 years as an example because both NETA and NFPA 70B generally use 3 years has a standard type maintenance interval. And there's reasons why you might want to do your maintenance interval more frequently or less frequently, but 3 years is generally standardized. So as I move away from that test date and I get closer to that 3-year test interval, the likelihood of that equipment working in accordance with the manufacturer specification starts to become less. How much less? Can't tell. But I know that if I'm at the 3-year mark or close to that 3-year mark, I want to be a little more cautious around that equipment. So it still gives me a lot of information that I need. 130.5, this is where we talk about arc flash risk assessments and everything. It says additional protective measures. If additional protective measures are required, they shall be selected and implemented according to hierarchy of risk control identified in 110.1G, which is our electrical safety program section. When the additional protective measures include the use of PPE, you have to identify the following: appropriate safety-related work practices, arc flash boundary, and the PPE to be used within the arc flash boundary. Then we get into tables. We talked about table 130.7 C15AA, the estimate of likelihood of arc flash. That was moved out of the table method and moved forward to 130.5. So we can use that table now independently of the table method. Table H.3b, which is an Annex H, that was cut down a little and moved to a standalone table in 130.5D. And the reason that table was moved forward is because being in the annex, people felt like there was really nothing they could use if they had arc flash warning labels on the equipment. And even though you tell them you can go to H.3b, they wouldn't do it. So what we did, we took that table and moved it forward to 130.5D, and we tell you, hey, look, use this table if you have arc flash hazard warning labels. Table 130.7 C15AB, arc flash categories for AC, is now table 130.7 C15A. Table 130.7 C15B, arc flash categories for DC, is 130.7 C15B. And 130.7 C16 for PPE selection is now being numbered 130.7 C15C. So now what you have in the table method is A, B, and C. Much more clear as to the numbering. The other numbering kind of drove me crazy. Just didn't seem to make any sense. So here's a partial view of table 130.5. And it says that it's the estimate of likelihood of occurrence of an arc flash incident for AC or DC systems. And we have a series of tasks on the left-hand side. And these tasks are tasks that are considered that regardless of the equipment condition, that an arc flash event is unlikely. And, you know, when I teach this electrical safety, I always like to point out that the word likelihood does not mean it's not going to happen. A lot of people interpret it that way. Likelihood means that it probably won't happen. It shouldn't happen. But you know what? It could happen. And if it does happen, then, you know, things might not go well for you. And you notice you look at working on control circuits, 125 volts, AC or DC or less. And, you know, if you're working in a control panel and all there is this 125 volt wiring, even if there was an arc flash, it probably wouldn't be of any consequence. But now we get into examination of insulated cable with no manipulation of cable. Well, you could get an arc flash off of that. I mean, the likelihood of it's pretty low. But there could be an arc flash. So you still have to evaluate each situation individually. But this helps as a guide. Table 130.5D, this is the table that we brought forward from Annex H. It's table H.3b. And there's only two ranges of incident energy. But within both of those ranges, it gives you a complete list of the personal protective equipment that you would be required to wear. So we have 1.2 to 12, and then 12 and greater. If you have an arc flash warning label, this is where you're supposed to go. Now, the equipment labeling section, we had to change the exception number 1 because the September 30, 2011 date was really getting gray in the beard. So we changed it so that as we go forward, it will still be applicable. Unless changes in electrical distribution system render the label inaccurate, which, you know what, you got a requirement in the 70E that already says if you have changes that affect the incident energy, you got to change the label out. But now here we're saying again, if the label is still accurate, labels applied prior to the effective date of this edition of the standard shall be acceptable if they complied with the requirements for equipment labeling the standard in effect at the time the labels were applied. So if you have labels and it talks about hazardous category 0 as an example, and that was acceptable at the time that the label was installed, you don't have to remove that label. Actually, the requirement for hazardous category 0 is still in the standard. It's just it's not required to be labeled. I mean, you still have to wear cotton clothing, safety glasses, and all the things that would go with 0. But it's not required to be put on a label. Exception number 2. Supervised industrial installations where conditions of maintenance engineering supervision ensure that only qualified persons monitor and service the system. The information required in E1 through E3 shall be permitted to be documented in a manner that is readily available to persons likely to perform examination, servicing, maintenance, and operation of the equipment while energized. One of the examples that we talked about were barcoding, or these new square barcodes that they have, where you could actually get a lot more information from that type of label than you would from a regular arc flash label. And if you have something where maybe you have a double-ended substation where sometimes you have one tie closed, sometimes you have both tie closed, you'd be able to go up, scan that, and be able to tell, you know, if it's in a single tie bus or bus tie being closed, it's going to be at this, but if both of them are closed, it's going to be this. So it's a way to allow technology to make the workplace a little more safe. And we don't want to constrain technology, so we're allowing for that here in exception number 2. Table 130.7 C15A, really the same table that we had before as 130.7 C15AB, has the same type of categories, but you'll notice where it used to say 240V, we now say 240 volts. One of the things we are changing that may not stay is changing short circuit of current available to available fault time or available fault current. There was some back and forth on this, and I didn't feel that people were really solid on it, so we may just keep it as short circuit current available, which would make me happy. And we're adding the word minimum to working distance, the minimum working distance. If you're closer than that, these tables don't apply. One of the things that we're adding 130.7 C15A is this new note, and this is out of IEEE 1584 and has typical fault clearing times of overcurrent protected devices. And you got current limiting fuses, you got molded case circuit breakers, insulated case circuit breakers, relay operated circuit breakers. There's a whole range of overcurrent protected devices here. And we know that in the past, when people have used the table method, they were kind of wondering, well, what should I use for fault clearing time? Well, here's some typical fault, and typical, you know, using words like this, people interpret it different ways. Here's the way I interpret typical. maybe not always. And if you don't, or I should say, you may possibly have a different fault clearing time than what this table gives you for any given overcurrent protected device. But you got to use something. So these are typical. And if you're using the table method, you're estimating, this is one way to help you estimate the applicability of your system. 130.7C15C really has not changed. We are adding the metric equivalent for all the values where it says 8 cal per centimeter squared, it's 33.5 joules per centimeter squared. And one of the things that we also did, any place that we have a metric value and an SAE value, or let's say US value, the US value will always be stated first, the metric will be stated second. And that goes against a lot of the other standards. And the NFPA and a lot of your other standards organizations are trying to harmonize their standards with overseas documents. Well, you know what? This standard is used primarily in the US, and we want it clear for those people that the standard is intended for. Now, we have the metric. You want to use it overseas somewhere, that's good. Here it is. But this is a US standard. We need to make it US. The other thing I'd like to point out, you come down to hearing protection. It says ear canal inserts. And we struck that out. And after a lot of deliberation, we decided, why should we constrain people from the type of hearing protection that they use? If it's covered so that any meltable parts won't ignite by either a balaclava or an arc-rated hood, you want to use earmuffs, hearing muffs, then that's fine. Go ahead and use them. But just be sure that anything that's flammable or meltable is covered. And I'm sure some enterprising equipment manufacturer will come up with some type of arc-rated earmuffs or something. We're putting a new note to table 130.7C15C. Rubber insulating gloves with leather protectors provide arc flash protection in addition to shock protection. I run into this all the time where people think that arc-rated gloves provide shock protection. Arc-rated gloves provide protection from the thermal effects of an arc flash only. If you want shock protection, you have to wear rubber insulated gloves with leather protectors. Now, the good news, W.H. Salisbury did a study where they arc flash tested rubber insulating gloves and leather protectors. And what they found is that they had extremely high values of protection from the thermal effects. And at one of the ASTM F-18 committee meetings I attended, one of the utility people stood up and said, I've never seen somebody with hand injuries that was wearing rubber insulating gloves and leather protectors. The gloves may be damaged, but the person's hands were fine. And I don't know that I've seen anybody that's really had hand protection if they're wearing leather gloves and leather insulating protectors or leather protectors. So you can wear what you like if you're racking out breakers or things like that. But if you're looking for shock protection, you have to wear rubber insulating gloves and leather protectors. 130.7C15 arc flash PPE category method. When the arc flash risk assessment performed in accordance with 130.5 indicates that arc flash PPE is required. And the arc flash PPE category method is used for selection of PPE, then you got to use the tables. That's what they're saying. You're using the table method in lieu of arc flash hazard warning labels because there are no arc flash hazard warning labels. That's why you use the table method. You're not supposed to use the the table method if you have arc flash hazard warning labels. If you have the labels, you're supposed to go by the label. Don't go by the table method. And then we go on to say the estimated maximum available short circuit current, fault clearing time, and minimum working distance for various AC equipment types or classifications are listed in table 130.7 C15A. An incident energy analysis shall be required in accordance with 130.5 for the following. And then we go through the list that's already in the 70E. If you exceed the available short circuit current, if you exceed the maximum fault clearing time, or if you are closer than the minimum working distance, you have to do an incident energy analysis. Can't use the table method. 130.7C16, this is brand new, personal protective equipment conformity assessment. All personal protective equipment referenced in table 130.7C14 shall comply with the associated reference standard. So what it does, it has a lot of people don't look at some of these tables, but it has all the types of test equipment listed, and then it has the standard that it's supposed to meet. So what we're saying, if you got safety glasses, they got to meet the standard. Effective January 1, 2018, all personal protective equipment shall comply with ANSI ICEA 125, American National Standard for Conformity Assessment of Safety and Personal Protective Equipment. Conformity assessment level 1, 2, or 3 in its entirety and shall be marked in accordance with Section 9 of ANSI ICEA 125. We got some manufacturers on the 70E committee, and they didn't like this at all because it's extra cost. And they're saying, well, it's hardly effective. But you know what? It's something that's needed. If you're buying something that's designed to protect people from the risks associated with operating and maintaining an electrical system, you need to have some assurance that the equipment is what it says it is. And that's what this is designed to do. Here's a good example. And I see mostly small contractors show up on the job site with this type of equipment. Now, I want to point out that just because it's green doesn't mean it's obsolete. There are manufacturers that make green arc flash suits that meet all the requirements of ASTM F1506. They're marked appropriately and all that. But, some of this is not. And this is an example. 6-ounce double layer Nomex, a single layer on the arms. There's no arc rating on it. It doesn't talk about 70E compliance on a label, and it doesn't say anything about ASTM F1506 compliance. It had a polycarbonate face shield, which up to 1996, when we started doing arc flash testing, we thought that polycarbonate was the way to go. Well, it turns out that polycarbonate face shield melts at about 1.5 calorie. And on the left is the label that is sewn into that green arc flash suit. And you can say it's got nothing about compliance with anything. Because at the time, there was nothing to be in compliance with. Well, now, this is the way, if you table on the left, this is the way the label should look. This garment meets or exceeds the requirements of NFPA 70E, ASTM F1506. It talks about the visor. It's got an arc rating, ATPV, hazardous category, which now will be PPE, arc flash PPE category. But, it tells you that it's in compliance with the appropriate standard. Here's a video that I have of arc testing of that same type of arc flash suit. And you can see that the chest of the arc flash suit held up pretty good, but that polycarbonate window melted and collapsed onto the mannequin's face. And as the saying goes, that will probably leave a mark. You don't want to trust your life to this type of equipment. If you see somebody show up at your job site, a contractor, if you have any doubts about their protective equipment being appropriate, ask to see the label. It should be marked either on the outside, which most of them are, but I have seen some that are only marked on the inside part of the label. You want to see that it meets ASTM F1506 and NFPA 70E. Now this is this one's really bad. I'm not sure where this clothing was purchased, but I'm sure they got a really good deal on it. You can see that I have over here on the right on this warning label, it says this garment resists ignition when exposed to flame or electric arc and will not continue to burn when removed from the ignition source. Hey, we're good. You go on, I've got a hazard risk category. That's good. I've got an ATPV arc thermal performance value 9.6. This thing looks pretty good. I think I got a pretty good deal. However, that 2112 is not a date. That 2112 refers to NFPA standard 2112. And it goes on to state, this garment meets the requirements of NFPA 2112 standard on flame-resistant garments for protection of industrial personnel against flash fire. Flash fire. Now, it's got an ATPV, it's got a hazard risk category. This equipment has not been tested to ASTM F1506. I have seen dual-rated garments. It says that it's tested to NFPA 2112 and ASTM F1506. But if it doesn't say that it's tested to ASTM F1506, this is not appropriate clothing to wear for an electrical worker. And unfortunately, people are buying this equipment because it's a good price. And, you know, in all honesty, maybe it's fine. But if this guy gets hurt wearing this clothing and he takes his employer to court, his employer is going to lose a lot of money. So that's a really good deal on this arc rated or apparently arc rated equipment that is not arc rated is going to turn out to cost them a whole bunch of money. So you got to make sure that it says it is tested to ASTM F1506. Otherwise, it is not arc rated. I don't care what other markings it has on it, it's no bueno. Here's something else that I found. We have a set of insulted screwdrivers. Now, I don't get a lot of confidence when I see that they spell insulated as insulted. And, you know, the thing is, though, I went to a major chain's website. I found those exact same screwdrivers. I mean, you can see by the way that they're marked down here, these are the same screwdrivers. And you can see they're at a bargain price of $3.16 a piece. I don't know that I would trust my life using screwdrivers like this. Will I save a lot of money? Yes, I will. Can I have any confidence in them? No. And speaking of confidence, on that same website, I could get an 11-function digital multimeter with audible continuity for the bargain price of $24.99, and it says compare at $54.99. Now, you know, here's where we want to go out on a job site with a $24.99 meter. The leads say that they are rated for 700 volts AC. And take a look at these test leads. I don't know that I would trust those babies at 700 volts AC. But wait, there's more. For the mere price of $5.99, as a friend of mine used to say, it's a mere bag of shells. $5.99, I can get a 7-function digital multimeter, and the leads are good for 750 volts. Look at that. And if you look closely, they look like the same leads to me, but they're 50 volts better. Man, I wouldn't use this thing. You couldn't make me use it. The last thing I really want to point up is that of counterfeit equipment. And this is a good example. I don't know why counterfeiters counterfeit the cheapest junk that they can find, but they do. And here I have a 3M household extension cord. And I mean, it looks all good on the inside. It says it's rated for 10 amps, 125 volts, but if you cut that thing open, it is not 16 AWG wire, it's 26 AWG wire. That is a fire waiting to happen. So that's the end of my presentation. I hope this helps everybody that's listening. If you have questions, probably the best way to contact me is through my email, jrwhite@shermco.com. Thank you very much.